Hello and welcome to today's webinar presented by O3 Solutions and Justin Francis, the ultimate data consumer, how O3 gives you the edge in efficiency. First up today, we're going to discuss a safety moment, and then I will give you a brief overview of who O3 is, and then I will introduce our speaker here, Justin, and then he is going to walk you through what makes O3 the ultimate data consumer, including 3D models, non-model data, handling imperfect data, model conditioning, dynamic model parsing, seamless fabrication data integration, and material integration. And then we'll provide you some key takeaways. And then if time permits, we'll allow you to ask us anything you'd like regarding the presentation. And with that in mind, you can submit your questions throughout today's presentation via the GoToWebinar chat question panel to the upper right button there, and then we'll get to those at the end. And then I'll give you a little bit of information you can take away and learn more and how to contact us. So with that, let's do the safety moment. And hey, Justin, your screen is not sharing. Your video's on, but your slides are not up.
Okay, let me share again.
There we go. Perfect. Okay. So quick safety moment as warm months are upon us. A lot of people are hitting the water, so some obvious things to keep in mind, but you never know. Keeping these at the top of your head could save a life. So things to understand of utmost importance: never leave a child alone around the water. Know your limitations. Never swim alone. Always wear the appropriate safety life jacket, especially while boating. Always swim sober. Alcohol can dehydrate you faster. And then understand the dangers of hyperventilation and blackout. And know when to call for help. Don't be afraid to ask for help, and be aware of the types of water environment you're in. From a river to ocean, water temps. There may be rocks or things under the water that you can't see. So just keep that in mind and stay safe this summer as you hit the water. So who is O3? We are the market-leading agile software built specifically to support AWP. We're the only solution on the market with true work package management, no matter the size of the project. From small cap to mega projects, O3 is scalable and can support your AWP maturity journey. So diving a little deeper, what makes us the market leader in AWP software? Well, we provide a multitude of things, including change management, collaboration, automation, scalability, and optimization. And these all support your AWP projects, as well as improve just overall project management functions on a site. So more than enough experience across the board here. You can read. And with that, I'll give you a little more info about each of our solutions, including appraisal and concept phase, front-end planning, detailed design and procurement, construction management and installation, test and turnover, commissioning and startup. And we have a solution for each of those buckets there, as you can see. And then, of course, an enterprise program that can help you manage a project portfolio. So with that, another quick snapshot of who O3 is by the numbers. We have been deployed on over 550 projects, and inside of that it includes over 10 owners, over 50 contractors, and over 10 EPC firms, multitude of solution areas, over 20,000 users. I believe that number is even higher than that today. And we can support over 10 work package types, all on one platform. I think that's the best thing to understand about O3. We do all this internally with one solution suite. So you're not having to use outside sources. It's all in there itself. And with that, it is also a very easy to use software. We have a 92% client satisfaction and a 58 NPS score. So just a little bit about us. Now let me introduce our speaker today, Justin Francis. Justin has more than 2 decades of international experience in engineering and IT. He has a master's in IT with civil engineering background. He's got a deep cognizance in the building, BIM, and oil and gas data formats, including plant, and then expertise in providing solutions for data migration and interoperability. He's responsible for providing major CAD solutions for a leading oil and gas company and directly managing outsourced CAD development for the past 20 plus years to various companies in Europe, US, Middle East, and Asia. He's developed and deployed software and technical solutions for mega projects that cost in US dollars multi-billions for the last 20 plus years. And to all that to say, he is more than qualified today to speak to us about what makes O3 the leading data consumer. So with that, I'll turn it over to you, Justin, and take it away.
Thank you, Tori. Hello, everyone. Good morning, good afternoon, or good evening, depending on where you are. I appreciate you all joining today's webinar. Please allow me a moment to turn off my camera so we can fully focus on the discussion. Today, we are going to dive into the critical topic of data. Why it is so important, why we are all talking about data, and why it's become so important in the industry, and how O3 handles the data when it's less than perfect. Let's explore the solutions that O3 offers to make data work for us, even it is in its imperfect state. Data is very important. It is the backbone of any process. However, we often encounter data that is imperfect or not in the preferred format. The true challenge lies in cleaning and validating this data before it can be used efficiently. While it might be feasible to clean and prepare data manually when dealing with the small volumes, the task becomes unmanageable when data is large, frequently revised, and inconsistent. One approach is to allocate many people to fix the data or outsource the task, but more sustainable and efficient solution is to use advanced software capability to analyze and fix the data automatically. This is where O3 steps in as an ultimate data consumer. O3 provide a rule-based tool to analyze, fix, and consume data, whether it's a graphical or non-graphical. Our system supports various methods of data integration, including direct import, API integration, and scheduled data consumption from flat files or other systems or from the shared locations. This approach not only ensures high data quality, but also minimize the risk of human errors when dealing with a large volume of frequently revised data. Let's explore how O3 excels in consuming data for work packaging, then move to fixing the data. Let's start with the non-graphical data and how we consume it. You can import non-graphical data such as equipment list, line list, foundation tags, etc. These are objects you want to package that are not available as 3D models, but are available as non-graphical data. This data can be imported through flat files, API integration, or stored in your preferred cloud location and periodically consume it from there. Creating construction components. O3 read the data and create construction components. Once it's created, these CCs can be used for work packaging. O3 treat both graphical and non-graphical construction components the same way. In addition to creating CCs, you can associate any additional data with these non-graphical CCs, just as you would with the graphical components, such as documents, bill of materials, drawings, schedules, etc. There is no need to have 3D models to work in O3. We support full non-graphical work packaging, complete with the constraints, drawings, documents, materials, RFIs, and more. Now, let's take a look at how O3 consume non-graphical data. You can see we have a material, we have an equipment list, we have some packages are associated with that, CWA and CWP, and also drawings, weight, and tag numbers and description. We can import this data into O3. Now I will use as a flat file import. And if we put a purpose, we say that we wanted to create a construction components, non-graphical construction components from this. Now the data is imported, and you can go to the construction component and you can see the construction components were created, and also it's associated with the CWA, CWP, and the drawings. You can see the CWA, you can open a CWA and you can see that the components are there. It's a single import. I mean, it's automatically associated with that. You can see the drawings are automatically associated with the CWPs. And now I will import the additional data. For example, I will import some material data to that construction component and see how it's imported and linked with everything together. We have the catalog codes, quantity and unit of measurement, and also we have the drawing and some additional data. So this time I will also select the flat file and I will say the purpose, it's a material takeoff, bill of materials, then it will import in the bill of materials table. And you will see that it's already linked with the drawings, and also it's linked with the component, and we did only 2 imports. In the 2 imports, it's already linked with the drawings and components and also packages. You can open a drawing and you can see that materials
Hey,
are.
Justin.
Yes.
Justin, sorry to interrupt you, but your screen stopped sharing again.
Okay, let me pause, and sorry, let me share again.
There you go.
Yeah, okay, let me okay, now we are importing the materials, and you can see the data in the material bill of materials, and also you can see that it's associated with the drawings. So we did only 2 import and all the association is happened. Now you can open the drawing and you can see that the materials are associated with the drawings and components are associated with the drawings. And if you have a drawing in your shared location, you will be able to see that drawing also there. So you can see the drawings now. In the drawing, you can see that it's the material and components are linked. And you can go to a CWA, and you can see that all the components belongs to that CWA is also linked. And also drawings are there. You can go to a CWP, you can open one CWP, and you can see that materials are associated with the CWP and also components are associated with the CWP. Let me move to the next. Now let's see how we can package these non-graphical components. So O3 support full non-graphical work packaging packages. Let me adjust my screen 1 second, please. Okay. So O3 support full non-graphical work packages, meaning O3 doesn't need a 3D model for doing the work packages, and we can perform full constraint analysis, generate work package report, complete a package approval cycle, update progress. Essentially, everything is available for non-graphical construction components except for 3D representation. You can manage all necessary tasks and data without needing a 3D model. O3 support hybrid packages, which means that you can have both graphical and non-graphical construction components in the same package. The system treats both the non-graphical and graphical package equally within the same package, providing a seamless hybrid work packaging solution. In addition to this, O3 allow you to link non-graphical CCs with its related graphical CCs to create graphical packages. For example, you can link cable list with cable trace in the 3D model, enabling full graphical work packaging. O3 intelligently identify objects based on their purposes and reflect this in the graphical packaging and visualization. This means you can select a cable tray in the 3D model and add them to a cable pulling work packages. The system identify the linked cables and add them to their related to that cables and the related data to the work packages. If the package purpose is a cable tray installation, the cable trays will be added to the work package along with their relevant data. O3 excels in consuming and utilizing available data. For instance, linking graphical CCs and non-graphical CCs can be done automatically if the relationship is present in the data. If these relationships are not available, you can establish them through a relational table and import it, or you can do it manually. O3 also support full graphical packaging. Very important. If you start with the non-graphical CCs and later receive 3D models during the project, what happened to the non-graphical CCs? They have materials, a progress update, and association with IWPs. O3 perform data migration so seamlessly that users won't even notice. All non-graphical CCs will become graphical CCs along with their related data, including drawings, documents, bill of materials, etc. No data is lost, and any additional data from the 3D model is integrated as well. O3 is very strong and efficient in managing data, ensuring smooth transitions and comprehensive data management. Now, let's see in O3 how we can package non-graphical construction component. We will then import the 3D model to see how O3 convert these non-graphical CCs to graphical CCs along with their all relevant data, including progress and package and all to their graphical counterpart. You can create a IWP in O3. This you can type an IWP number, or this can be by rules. It will create IWP number by the CWP numbers, and you can put a description, and also you can select a CWP. So the object will be filtered, so it will be easy for the workplace planner to select the objects, and you select a purpose for the IWP. Now we save the IWP. Now we can go and import the non-graphical construction components to this IWP. We select the construction components and we add to this package, and then you will see the material is already linked with the IWP. It's already available in the IWP, and also the execution task is created, estimated hours is calculated. If you go in IWP details, you will see the total hours are calculated, key quantity is calculated, number of unit of measurement is calculated. Now you can use the proper workflow of the IWP. This is a non-graphical one. Then you can move to each and every stage of the IWP, because I wanted to update some progress. Now it is in the progress stage, and you can go to the execution task, and then you can update the progress. So I will update some progress now. I will save the changes. And now you can see that it's in the status is in progress, and now we have some progress. Now I will import the 3D model, and some of this non-graphical components is available in the 3D model, so it will become the graphical component, and see how we can take all the data from the non-graphical to the graphical. So I'm importing a 3D model now, and now we can load the 3D model. And you can see that it's all let me pause a little bit. You can see that's already that component have a CWA and CWP, so it's created the workplace planning tree for the graphical one. So we didn't do anything, we just imported the 3D model. It's checked in the behind which component was a non-graphical, so it's took the data from the non-graphical and now it's created the hierarchy for you. So you can see the CWP. Now you can see that we already these components are in IWP, so you can see that it's already added to the IWP as well. So you didn't do anything, you just import the 3D model, all the data migration behind it's happened automatically. Now you can select a 3D object and now you can see the data. Some data is updated from the 3D model. Now the new data is coming from the 3D model and it's updated that construction component, and you can see all the association with it's there with the drawings and everything. It's coming non-graphical one. Some of them become graphical and the rest is the old one, the non-graphical one. Now we can select one CC and see that it's linked with the 3D model.
Hey, Justin.
And
Sorry,
yep,
we lost your screen again.
oh, sorry about that.
There we go.
Yep. So, let me go back a little bit. 1 second. Yep. And okay. So you can see that some of them still are non-graphical and the others are the graphical one. So okay, let's move to the how we can handle the imperfect data. Now let's take a look in how we handle imperfect data, see how we can eliminate the erroneous manual fixing by using O3's rule-based data analyzing and fixing engine. So let's start with a non-graphical or non-model data, then we will go to the graphical one. We have a functionality called a data deliverable. Data deliverable is a feature that allows you to analyze and fix the data when importing it into the system. User can write rules for analyzing data, and based on the result, O3 will fix the data before it is consumed. We have a lot of features with the data deliverable, and this feature is very useful for handling imperfect data. There is no need for coding or scripting or fixing your data outside the system. It is a powerful and user-friendly interface that allow you to write rules and fix the data. User can create data deliverable and associated with them with a particular import, and the rules will execute automatically each time. It has a lot of features. I will show a couple of them. For example, the field mapping. O3 allow users to map source and destination field effortlessly. You don't need to have the source field to have the same as the destination field. You simply map them and the data will be imported. If your data is related to work packaging, O3 can automatically assign it to the appropriate packages. So as you have seen, I mean, when you import the construction component, it's already assigned to the package, so the import it will take care of it. And you can also rule-based data analysis and fixing. With the data deliverables, user can write rules to analyze and fix the data before importing it into the project. This is a powerful feature to save countless man hours by ensuring data accuracy and consistency from the very start. You can specify multiple fields to data lookup within the with priority. If one field lack of value, the system automatically check the next specified field, ensuring data completeness. Data deliverable support advanced math functions. You can create and apply formulas directly within O3. You don't need to use Excel sheet and write the formulas there. Data deliverable offers a comprehensive string manipulation functions, allowing you to modify and manage text data efficiently. O3 support data comparison, enabling actions based on the comparison result. Linked with the data sources, tag and specify the source of your data, such as this data is coming from the material management system, or it's coming from the contractors, or coming from vendors. So within O3, a better traceability and organization of the data. You can easily classify the data during import and make the data management more efficient and organized. Link with the drawings and resources. Data link with the drawings and resources if they have a valid relationship, enhancing the connectivity and the usability of the data in your project. And also very important, you can integrate missing data, easily integrate with any missing data during import, or we also support the post-import functions, ensuring your data is always complete and accurate. This is all automated. I mean, you don't have to do anything manually. For graphical data, we have another feature named parser configuration, which support all data deliverable functionality plus additional capabilities such as creating construction components from the graphics, model conditioning, integration with the fabrication data, creating additional geometry for fabrication data and material takeoff, and etc. These powerful features allow users to analyze imperfect data and make it sustainably usable for construction. Now I will move to another major feature. It's called the model conditioning. Model conditioning is a very powerful feature in O3. Let me give you some details. I'm sure you have often encountered situations where your 3D model contains many unnecessary objects and you don't know how to get rid of them. Typically, you would need a 3D model expert to advise you. But even then, there might not be a satisfactory solution. You are often forced to use the model as is, and all the relevant element will be inside the model when you use that model. This could include non-construction objects, out-of-scope areas, relevant disciplines, or objects are not part of the current work scope, etc. This situation can significantly affect your workflow, making the model cumbersome, reducing performance, and creating inconvenience. To address this, many companies hire experts or even outsource the model conditioning task to third-party consultants, sometimes even sending your model to overseas. This process becomes even more problematic when dealing with model revisions, as the same costly and time-consuming procedure need to be repeated. Additionally, relying on the other software for model conditioning bring extra cost, and you never fully know how the conditioning is being done, creating dependency and potential risk. O3's rule-based model conditioning steps in as a savior, saving you both time and money. This powerful feature allows you to streamline your 3D models, removing unneeded objects efficiently. As a result, you end up with a lightweight model that consumes less memory and deliver better performance. Within O3, you eliminate the need for any with O3 you eliminate need for any external export or third-party software, or ensuring a more efficient and cost-effective workflow. Let's compare the traditional model conditioning workflow with O3's model conditioning workflow. In traditional approach, when you receive a 3D model from engineering, you often cannot use it immediately. You have to manually condition the model or send it to a consultant company to do it for you before it can be used in your AWP solution. This process brings a significant cost in terms of time, quality, and money. the manual processing is prone to human errors, require expert knowledge, and it's expensive. If you handle it internally, you may need a highly qualified personnel with the expertise in many softwares. Additionally, with a frequent model revision, the entire process must be repeated, further escalating the cost and effort. O3 offers a very different approach. With the O3's model conditioning, we have a dedicated module for this, and it is rule based, allowing you to simply define your rules without need for any coding, scripting, or complex queries. Our rule engine features a very user-friendly interface where you can write multiple rules easily. These rules can be attached to model and will automatically execute and do the conditioning of the model before it's consumed by the system. This approach saves time, ensure high quality, minimize risk of mistakes, eliminate manual work, reduce additional cost, and remove the need for the external software expertise. Now you can see the result. The initial model without the model conditioning contain all objects from the original model. The next image shows the sum objects after enabling the model conditioning. This conditioned model is a clean and neat, containing only the object need for the scope. For example, piles that were not in the scope, and we have removed them using the model conditioning. This result a less memory consumption and faster loading time and providing additional benefit. Now let's have a look in O3 at the model without conditioning, and then a model with the same model with the conditioning. You can load the model without model conditioning. You can see all the models are there. The piles were not in the scope, but it's still there in the model. And you can see that there are some far objects, and you can see some big volumes, the trucks. They are not the construction objects, and it's also hiding some. You can see that it's also hiding some loading platforms, and also there are some volumes which are not needed for creating the work packages. Now you put the model conditioning rules, and now you load the same model again, and now you can see that all the unneeded objects were gone. Now the piles are not there, the big volumes are removed, and you can see that the vehicles are not there, and also you can see that there are a lot of volumes on the steel structures are all removed. They are not construction objects. So now the workplace planner can just focus on the object that he needed for creating packages. So now let's move to the parser configuration. This is also very important feature in O3. So the purpose of the parser configuration is to create digital construction twin or virtual construction model for AWP scope. This step is crucial and mandatory for using 3D model in AWP context. Because it's mandatory, it needs to be easy, efficient, and accurate. First, we need to understand the scope of the work you were planning to do with the 3D model. Like in your previous example, piles were not in the scope, so we should not create construction components for the piles. Also, we don't want to see the piles in the 3D model, so we can focus only on the objects that are in the current scope. Once the scope is clear, O3 steps in with a rule-based engine to create the construction components from your 3D model. For instance, if you are building a pipe rack using the stick build method, which involves both fabrication and erection, your CC will be steel assemblies that perfectly match your stick built members. You will be able to attach different data sets for various scope of work, such as materials, drawings, and different execution steps. O3's parser configuration is incredibly user-friendly. It is a rule-based engine that require no scripting or coding. You can define simple rules to identify the CCs. For example, you wanted to identify the assembly and create a CC. So you identify the properties of the assembly, then uh, O3 parser configuration will create the CCs for you when we parse the models. If your 3D model lacks certain data, O3 provide option to easily integrate data from different sources, making it native to the CC. Throughout this process, CCs can be assigned to package, drawings, systems, and subsystems, and can even create bill of materials automatically. These features work hand in hand with model conditioning. Depending on the scope, one graphical object can be part of unlimited number of CCs, saving each stage of the design and construction process exactly as required. As I mentioned earlier, all functionalities detailed in data deliverables will also available in the parser configuration. Now let's compare a traditional approach to create a virtual construction model with the O3 parser configuration approach. First, you receive a model from engineering. Then you need to analyze the model data with the external tools. You might have internal resources for you, or you might need to rely on third-party consulting company, requiring you to send the models to them. They use external tools, scripting, and sometimes export the data to flat files like a CSV and write rules to create construction components, or develop a custom tool to identify CCs. After preparing everything externally, you bring it back to your AWP software to create a digital twin or virtual construction model. When you receive the model revision, you repeat the entire process over and over again. This approach involves significant cost and time, and, and often compromise with the quality. It is not sustainable, and people might try to convince you otherwise because their software cannot handle this level of data management. This approach take more time, compromise quality, increase the risk of human errors, require huge manual effort, creating very high recurring cost, and demand high expertise in external software. Now, let's see the steps involved when you use O3's model parser to create the digital construction twin or virtual construction model. First, you receive the 3D model from engineering. You can analyze, create rules for construction component using our rule-based engine, which is compatible with reading and analyzing data in the 3D model. Once we identify these objects, the parser configuration allow the users to read data from even from the parent or child of the object, and that data can become the part of the CCs. For example, if the CWA and CWP information is available in the higher level or the child level, or any children has this information in the model hierarchy, it can easily be included in your CC by rules. We save rules with the 3D model. When we receive a revised model, system will automatically pass through the CC's rules and update the CC's based on the revised data. Any additional information can be integrated to CC's and preserved during the subsequent revisions import if desired. O3's approach takes significantly less time and fully automated. As soon as the model from the engineering is available, it will be available in O3 as well. The quality is high because the object identification is based on rules, eliminating risk of mistakes when revised models are received. No manual interaction is needed for handling the revised model. There is no additional cost and no external software or expertise is required. If no parser configuration is used, you can still view the model in O3 with its native properties, but you won't be able to perform work packaging. When the parcel configuration is used, models objects are converted into construction components, and these construction components give specific purpose in the project, enabling their use in the graphical work packaging. Now let's compare the models in O3 with a parser configuration and without a parser configuration. I will load a model without a parser configuration, and also you can see that the red icon here, it says that this model is just a model. It didn't go through the parser configuration and creating construction components. You will not get any workplace planning tree or construction component layout, and but still you can see all the properties of the model inside O3. You can interact with the 3D model. You can select objects, you can see the hierarchy and the property, but you cannot use this object for packaging. Now I will open the same model with the model parsing. It's went through the model parsing rules, and now you can see that CWAs are created. All the construction components were associated with the CWAs, and also you can see the workplace planning view, which with the hierarchy CWA and CWP and IWP hierarchy, and also now you have the construction components, and now you can use that for the packaging purpose. And you can switch to CWP and see all the CWPs belongs to that model, and also you can isolate a package, and also you can turn off a discipline, or you can turn on a discipline. And now these objects has purpose now, and all the material drawings and everything is associated with these objects. And when you take this object to a package, everything based on the purpose of the package, the resources will be added. You can select a construction component, and also you can see its details, subcomponents, and work package, associated work package, and so on. So let me now go to the fabrication data. So it's very important to understand the fabrication data, how we consume. O3 is a powerhouse when we consume and integrate the fabrication data into the system. The key is to understand why we need to bring the fabrication data in, where it will be used, and how it will be utilized. All these factors are taken into account when we integrate the fabrication data into our system. It is not merely about importing fabrication data as an additional properties group attaching to your design counterpart. O3 analyze the fabrication data and create construction components from it, linking them with their design counterparts. While reading the fabrication data, O3 create additional properties based on the scope. For example, it identifies the previous and next connected components or spools. It calculates inch dia, it calculates inch meter, and performed material takeoff from the fabrication data. From the geometric perspective, O3 generate the geometry for any component that lack graphical representation in the 3D model, or any component that are not exactly matching with the fabrication geometry in the 3D model. For example, we generate the graphical components for the gaskets, field wells, splitted pipes, etc. For example, during the spooling process, long pipe might be split into different spools or field runs. O3 create pipe based on the fabrication data, ensure one-to-one match between the digital twin object and physical object being created on site. Furthermore, O3 groups objects for convenience for workplace planners, such as grouping gaskets, nuts, and bolts as a flange union, and create one geometry for that. this is an option if you wanted to interact with that, or you can create different geometries, one for the gasket, one for the nuts, one for the bolts. When reading the fabrication data, O3 support full geometric transformation, including translation, rotation, and scaling to match design location and fabrication geometry accuracy. This is also ensure accurate quantity calculation. O3's rule-based data processing engine provides full support for analyzing and fixing any data issue during fabrication data processing. We analyze the fabrication data before importing it. If there is anything is not correct, we also give you a very detailed feedback in the fabrication data why we cannot have it in as a fabrication data, because the data is wrong. So it's not just importing something as a from the file. It is really processing and analyzing the fabrication data before we consume it. Let's see how we integrate fabrication data in O3. Notice that there is no need to load PCF or IDF model separately. If an isometry has a fabrication data, it will automatically be loaded with the 3D model. So you don't have to load the fabrication data separate. It will load, O3 will find its related fabrication data and it will be loaded for you. Let's see the fabrication data, how we can see in O3. Now I loaded a isometric, and it's also you can have a CWA and CWP, and also we have, you can see that we have let me stop. We have 4 isometric, and one of them has a fabrication data, and so we can expand and see the data is coming from the fabrication. Others doesn't have the fabrication data, that's stop till the design level. So you can see that the spools, and also you can see the field fittings. Now we can have you can see the select this spool. We have 2 spools, and also we have the field fittings. Now you can see the details. Now you can select the spool, and you can see all the detail. It's coming from the fabrication. And also let me stop. Now you can also see that the connected component, this spool is connected to a valve, and also previously it's connected to another spool. So all the details are calculated from the fabrication data. And also it's calculated its inch dia, inch meter for the particular spool, and also it's associated with work packages, and also it's associated with the drawings, and also it's classified as an isometric drawing. So you can see the subcomponents, even subcomponent, let me pause again. Subcomponent is also, you can see that the previous one is a T, this is the one we are talking about, and our next one is the elbow. So when you add to this data to a fabricators, they don't have to open the PCF file or the software, or they don't have to open the spooled isometric drawings. They can get all the information from the O3, and when you add to that fabrication package, all this information will be available in the fabrication package. So everything, when we consume the data, we really use that data efficiently and make it ready for the workplace planners or the fab shop people. You can see now field fittings. You can see that some of the geometries, that the green one we created, that's the flange union. Flange union is the group of components. You can have the different one, but here I grouped as a single component. You have the container, that the container have the flange union header, and also the same strategy, it's a connected components and everything is there. And you can see that a description shows that it's a flange union. Then you can see that now you can see that the another one we have this is a gasket, and also you can see its quantity of the gasket. And now we have another component in the flange union, which is the nut, and also you can see the how many nuts are in that particular bolt up. And now you can see that bolts and number of bolts, all information, it's available in the system now. and you can see that all the associated packages. Now you can take another welt. Now you can see that I select welt. Welt geometry is created in the O3 because it's a field welt. We don't have that in 3D model. It's inch dia, and also you can see the welt details. Now you can okay. You can also see it's weld with what? I mean, it's weld with a T, and also it's weld with a pipe. So all the information is available there. So, and also you can see all the weld attributes is ASCII, and all the details are now available in O3. Okay, let me move now to another topic. It's a material takeoff. This is the last topic, but I will show you how O3 dealing with the materials. Let's look how O3 consume materials. When it's come to materials, O3 is an ultimate consumer. We can consume material from different sources and link them with their respective construction components. Whether it's a graphical or non-graphical, doesn't matter. Bill of materials can be integrated into O3 through direct import or API integration or periodic consumption from a shared location such as BIM 360 or SharePro and or any of your repository. And additionally, O3 has a dedicated module for creating bill of materials within the system. This capability is crucial for project elevating O3 as a ultimate data consumer. O3 support bill of material, takeoff in with a wide range of functionalities. Consider a scenario where you are using a steel fabrication model which serves as a basic model for generating bill of materials for your steel scope of work. In traditional workflow, you would import the 3D model, then import the materials of the 3D model separately and link them together. It's need a lot of work and a lot of configuration. However, material takeoff is generated from the same model and you have in your AWP solution. Therefore, O3 offers an option to generate material takeoff from within the same model, ensuring fast and accurate process. There is no need for multiple import or asking project team to generate the material takeoff for you and send it in separate import. Simply get the revised 3D model and O3 will automatically generate material takeoff when consuming the 3D model. So everything, we try to avoid multiple imports. When the data is there, we wanted to really consume the data and use it. That's why we say that we are a ultimate data consumer for AWP. O3 support very detailed bill of materials takeoff. Moreover, you can have multiple versions of bill of material for the same CC within O3. For instance, you can have bill of materials pre-AFC, bill of materials from IFC, bill of materials from the fabrication data, and so on. When consuming bill of material for a specific purpose, O3 allow user to specify which bill of material should be used. Regardless of source from which the bill of material is integrated into O3, once materials are tied with the CC or drawings, all functionalities related to bill of materials will be available and behave consistently. You can see the bill of materials view in O3, which include its material source, category, and status. Source indicate where the bill of material is generated from, while the category describe the scope such as it's a field or a shop. The material status shows the current status of the material. This information is used to visualize the material allocation status graphically and also linked with the constraints and inventory. Material takeoff in O3 allow for storing many additional properties and dimensions. Additionally, material catalog, we can have unit rates that can be used to create material quantities when generating material takeoff. Now, let me show you how materials are stored in O3, and these materials have been generated from the piping fabrication data PCF. So you can see that the the PCF spools are created as a construction components here, as under its isometric. You can select a spool and you can see the material takeoff. Here you have the spool identifier as a component identifier. You can have the catalog code, description, quantity, unit of measurement, and also category and associated drawings. So you can see that the spools, I will take one spool and you can see its material. So now you can see the materials. You can have the categories of the material and its weld. For example, let me pause a second. You can see that we have two welds, shop welds, inch dia 28 and total weld is 26, and another weld is 18 and total weld in that spool for 18 is 18 inch dia. And also you can see all this categorized. It's the category when you create an IWP for the prefab, this data will be associated with that particular package, and all the everything is properly classified. It's just an import. We are just importing the PCF file. Everything will be calculated automatically. Now you have the field components. Let me pause again. Then you can see that the one piece that will be, you are taking this piece for installing at site, and you can see it's inch dia, and also you can see it's inch meter, and so on. And also you can see the additional information, and it's a main bore size and so on. Now I will take a flange union example because we saw that it has a container and it has data. Now you can see that it has three components. You can see the catalog code and the description. We have the gaskets, nuts and bolts, and the quantity. It's coming from the PCF. And I will show you one more example. For example, a valve. I will take one valve, the field component, and it's a very small one. It's a 1 inch, and also you can see the additional weight in case workplace planner wanted to know the weight of the valve when you add to the IWP. So all the data needed for the workplace planner properly is available in the system now. Let's discuss some key takeaways before we close. One thing, and many things I wanted to make very clear: O3 does not require a 3D model for work packaging. Absolutely, we don't need it. O3 support full-fledged non-graphical work packaging. User can create non-graphical construction components and link them with the necessary resources such as drawings, documents, schedules, material takeoff, execution tasks, and so on. O3 does not need perfect 3D model data for graphical work packaging. In most cases, this is the scenario when it's come to data. If you wait for a perfect model with all the necessary data for work packaging, it will never happen. The power of O3 lies in the data integration and fixing capabilities. We can integrate missing data into the 3D model and use it as native data for work packaging. O3 does not require external model conditioning. If your project needs model conditioning, you don't need to do externally. O3 provides a rule-based model conditioning within its system. There is no need to depend on third-party software or companies to perform model conditioning for you. O3 does not require external model configuration. There is no there is one big trademark of the O3 is the parser configuration. It is a very intelligent and real-time and dynamic and flexible rule-based model processing module, and we called it a parser configuration. And then there is no need to use any external software or team of consultants or to prepare your model for your IWP scope. O3 is the model parser. O3 model parser is your built-in consultant. You just set the rules once and O3 take care of the rest. O3 seamlessly integrate fabrication data. You have already additionally, O3 can handle custom fabrication data format by easily configure our reader to accommodate any custom data formats. O3 support material takeoff. O3 has a rule-based and purpose-based material quantification module that generate accurate bill of materials for both graphical and non-graphical construction components. This is I wanted to highlight. We release bi-weekly at O3. We believe a continuous improvement, which is why we release a new version every 2 weeks. These updates include features requested by our clients and innovative solutions, ensuring you don't have to wait months or even years for critical features. We prioritize the security and the quality of your data. O3 committed to ensure the safety of your information adhering to SOC 2 compliance standards. The commitment reflects our dedication to providing a secure and high quality platform for your project needs. Thank you for all your time and dedicating for these sessions. And Tori, over to you. Any questions from our audience?
Yeah, thank you, Justin. Lots of excellent and thorough information to take away there. So we're running short on time, so I'm just gonna go for a couple questions here. First up, are features like model conditioning included as standard features, or are they additional features?
Yes, model conditioning is included in the as a standard feature, and there is no extra license or cost involved with that. If you have a O3, you can use model conditioning, inside the O3.
Great. Okay, next question. How does O3 address security concerns, especially when dealing with sensitive project data?
Yeah, this is very important, and I have explained. I mean, security is our top priority, and the O3 compliance with the SOC 2 standard, assuring users that their data is a high, we handle very securely. Our commitment to SOC 2 compliance is reflect our dedication to maintaining in the highest standard of this data security. So, your data will be very secure, and we have a dedicated team for this to update all the security things, and each release, we even update the any kind of security concern. We are update, and your data will be very secure in O3.
All right, let's do one last question. Will model conditioning support all types of models, or does it only support certain models?
It's a very good question. Model conditioning support all types of models. We support all major format, including SmartPlan 3D, E3D, Tekla Structure, Revit, Navisworks, and so on. And you don't need to even convert the models to NWD format to use in O3. We read them directly and apply the model conditioning before it's consuming the data and geometry into the project. One more thing, in the model conditioning, it will make model light. It's not, it will make the model clean, and also the model will be light. I mean, all the condition object will not consume any memory anymore, and also all the data we are avoiding from the model, it will not consume any memory. So the model condition is a very powerful feature, and that will make your model very light and easy to use in O3.
All right, awesome. Thank you so much, Justin. So with that, we're a little tight on time. I'm going to leave you with a few ways you can follow up with us. If you still have questions, we'd love to hear from you. You can email us at info@o3.solutions, or you can visit us at our website, www.o3.solutions. You can find a multitude of resources there for free at your disposal. You can find all of our case studies where we've had clients have real-time success with all of these different solutions we've discussed. And then you can see our past webinars on a variety of topics, as well as videos regarding our solution suite and other industry trends and topics. And then just follow us on social media so you can always stay up to date with what we're doing and our next events. You can also sign up for our newsletter as well. With that, I will thank Justin for presenting, and thank you all for taking time out of your day to join us. As a reminder, I will be emailing you this along with a copy of the slides. And thank you again. And please follow up with us if you have any more questions. Have a great rest of your week.
Thank you.